and welcome back to my YouTube channel. My name is Professor Govalla, and today I'm going to be talking to you about two examples, specifically a summing amplifier and a difference amplifier. And before we dive into the examples, maybe pause the video and see if you can complete these circuits and follow along as I solve them. But before we start, we want to first identify what a summing amplifier is, as well as a difference amplifier. And a summing amplifier is an op-amp circuit that combines several inputs and produces an output that is the weighted sum of the inputs, right? So briefly put, if you have a voltage 1, imagine this is a microphone. Let me call this mic 1, and it's your voice. So you're speaking into it similar to how I'm speaking into this mic. And I'm trying to make a music video, and I want someone to be speaking with me in the background. And they have a mic 2, and this is their voice, another person's voice. I can use a summing amplifier and combine both our voices. So I'll amplify it by a signal A, or AV, times V1, so mic 1, plus V2, mic 2. So again, this is basically what a summing amplifier does. And again, it's used in things like combining tracks together. So let's go to the difference amplifier and define that. And a difference amplifier is a device that amplifies the difference between two inputs, but rejects any signals common to the two inputs. So that's very important, right? So, and it's used in many applications. So in terms of our example, imagine I have V1, which in this case is mic 1, similar to the mic I'm talking to right now. And it's my voice. So my voice, and right now there's a fan behind me, and there's a fan noise. So this microphone actually picks up both of those. But then imagine there's another mic, or let's call this mic 2, and it's just picking up the fan noise, right? So essentially a difference amplifier is going to say, okay, let me amplify this and take the difference V2 minus V1. So this is going to be A times the fan noise minus my voice plus, there should be a plus the fan noise. And essentially, as you can see, this distributes to be minus and a plus. So my voice and a plus, and a minus. So then this cancels out with this. And what happens is I get AV times negative my voice is equals to V out. And if you wanted this to be positive, you could just pass it through an inverting amplifier and or inverting op amp, right? And again, check out my other videos in order to see what the inverting op amp looks like. But essentially, we'll pass it through, and this will become positive. So I hope that makes sense of why we need the difference amplifier and the summing amplifier. So let's go ahead and do these two problems, starting with the first one. So what I'm going to do first is I'm going to start off by labeling some nodes, or nodes that are unknown. I'm going to call this VB, or actually let me use a different color. Let me use red. So let me call this VB and VA. And we know that there's the current going in here for an ideal op amp and in here is 0, right? And we also know that because the current going in there is 0, we know that VB is equals to VA. Again, check out my other videos on op amps to see the proof of this. And we want to do a nodal analysis, or you can call it a KCL. we want to do a KCL at node B. And so that means that the current going in from here to here and the current going from here to here need to equate to 0. So let me call this I1 and I2. So I1 plus I2 have to be equal to 0. And I1, or this becomes V1 minus VB over R1 plus V2 minus VB over R2 have to be 0. What I'm going to do is I'm going to move this and this to the right-hand side, and I get VB 1 over R1 plus 1 over R2 is equals to V1 over R1 plus V2 over R2. I hope everyone follows the algebra in this example. So then VB, I'm going to multiply this by, this becomes R1 plus R2 over R1, R2. And we can equate that to V1 R2 plus V2 R1 over R1 R2. And I can say then that this cancels out with this, and VB is equals to V1 or R2 V1 plus R1 V2 over R1 plus R2. All right, so I hope that makes sense. So now let's write an equation for VA, and we could say then that VA minus, or let me use it in terms of currents first. So the current that's coming in here, so let me call this I3, has to equate to the current leaving I4, because again, no current flows in through here. So I3 has to equal to I4. So then we get 0 minus VA over R3 has to equal to VA minus VO over R4. We can go ahead and solve for VA. So we get that this is going to be VA 1 over R4 plus 1 over R3 is equals to VO over R4. And essentially, just let me slow it down here. What I did was I moved this to the right-hand side. Okay, that's this term. And I moved this term to the left-hand side. I made it positive. That's this term. So I hope that makes sense. So let's continue. Then this becomes VA times R4 plus R3 over R4 times R3 is equals to VO over R4. I can go ahead and cancel this R4 with this R4. And lastly, VA is equals to VO R3 over R4 plus R3. So I hope that's making sense so far. And essentially, what we need to do now is we know that, again, from this equation, VA is equals to VB. So what we can do is we can equate these two. We can equate these two as VO R3 over R4 plus R3 is equals to R2 V1 plus R2 V2 over R1 plus R2. And as you can see, VO is equals to, this becomes R3 plus R4 all over R3. Oops, yeah, all over R3. Okay, and then we multiply that by R1 plus R2, and all that is multiplied by R2 V1 plus R2. So this should be R1. So then this is R1 V2. So as you can see, this term here is what we call the weighted sum. So V1 is being multiplied by this weighted sum here, and V2 is being multiplied by this weighted sum here, and we're adding the two to get V out, similar to the mic 1 and mic 2 example that we saw earlier. And essentially, the problem was asking us to prove this. I forget to state that in the beginning, but essentially the problem was asked to state that VO is equals to R3 plus R4, R3, R1 plus R2 times R2 V1 plus R1 V2, which we clearly did. Okay, so let's move on to the second problem. If you have any questions, please leave them down in the comments section below, and I'll be sure to get back to you. In the second one is pretty easy if you know which formula to use. VO diff, this is a difference op amp. So this is equals to R1 plus R2 plus R1 over R1, R3 plus R4. There's a times R4 here, and times V2 minus R2 over R1 V1. Another way you might see this written in books is as R2 1 plus R1 over R4. R1 over R2 over R1 1 plus R3 over R4 times V2 minus R2 over R1 V1. So again, these equate to each other. These two equate to each other, and depending on how you solve for the difference amplifier, you might get either one of these, and they're the same thing. So essentially, we want to prove this. So the problem becomes very simple when you consider that this is R4, this is R3, this is R1, and this is R2. But let's go ahead and prove this. So the goal of the problem is to find VO when V1 is equals to 1 volt and V2 is equals to 2 volts. So again, if you want to pause the video and see if you can solve it, I'm sure it's pretty simple. You just plug this into this equation or this equation, and you should get an answer. But let's prove this for the audience and so you can see it before we just plug and chug. So again, I'm going to start off by saying that for an ideal op amp, this is VB, and this here is VA. And for this one, I'm going to do nodal analysis, where nodal analysis says the currents that are leaving a node have to equal to 0 to conserve the conservation of charge. So let me say this is I1 and this is I2. So we say that I1 plus I2 is equals to 0. So I1 is VA minus V1 over R1 plus VA minus V out over R2. Again, as you can see, this is my VA. I'm subtracting it from V out and dividing it by my resistor, which is a current in total. So this is equals to 0. So then I could say that VA is 1 over R1 plus 1 over R2 is equals to V1 over R1 plus V out over R2. And what I'll do is I'll solve for both equations. So I'll solve for this equation and this equation, just so you can see that they are the same. So in order to do that, I'm going to write this equation. Let me call this equation 1 as 2 equations. So I'm going to solve for VO. I'm going to say that VO is equals to VA times 1 over R1 plus 1 over R2 minus, well, this would be a times R2 minus, again, it's an R2 here, divided by R1 V1. Again, this R2 is coming from here, doing some algebra. So I hope you follow on that. If you don't, please leave down in the comment section below and I'll be sure to clarify that. So let's leave this. Let me say that this is 1A. And also, again, from equation 1, let me solve for a VA. So I'm going to say VA is R2 plus R1 over R1 R2 is equals to V1 R2 plus V out R1 over R1 R2. Again, these two cancel out, and we're left with VA is equals to V1, or let me write the R's first. So R2 V1 plus R1 VO over R2 plus R1. So then what we can say is that we have these two equations. Let me call this V1B. So there's two routes we can take. We can either just keep this in mind. We can either take this route or we can take this route. And we'll prove both are the same. So now the next step is to write an equation for VB. So again, using nodal analysis, I'm going to say that the current leaving here and the current leaving out here, so I3 and I4 have to equal to each other. So let me zoom out so you can see. So I'm going to say I3 plus I4 has to equal to 0. I3 is VB minus V2 over 2, or in this case, let me be abstract, R3 plus VB minus 0 over R4 is equals to 0. Let me go ahead and solve for VB and say that VB 1 over R3 plus 1 over R4 is equals to V2 over R3. Again, this is VB R3 plus R4 over R4 times R3, which is equals to V2 over R3. So let me solve for VB. So VB is equals to, again, this R3 cancels out with this one. So I get VB is equals to R4 V2 over R3 plus R4. So now we know that VA, we know that because it's an ideal op amp, VA is equals to VB. So I can go ahead and put this in here, or I can go ahead and equate these two, because this is VB and this is VA, so they have to be the same. So let me go ahead and consider two cases. So let's call this case 1, and let's go ahead and input VB into here. So we get VO is equals to VA or VB, since again VA is equals to VB. This becomes R4 V2 over R3 plus R4. And actually, I'm going to write the R2 last. So this is times 1 over R1 plus 1 over R2 times R2 minus R2 over R1 V1. So what we can do here is I'm going to simplify this. I'm going to say R4 over R3 plus R4. And I'm going to consider that this is R1 plus R2 over R1 R2 times R2 minus R2 over R1 V1. As you can see, there's a V2 here, and there's also a V2 here. As you can see, the R2 cancels out with this one, so I'm left with this equation. But what I'm going to do now is I'm going to say that R4, I'm going to pull out an R2. And if I pull out an R2 from the numerator, I'm left with a 1 plus R1 over R2. Again, as you can see here, if I multiply this by 1, I get this term. And if I multiply this by R2, I get this term. So I'm just pulling out an R2. So I hope that makes sense. And let's keep going. In the denominator, let me say that this is R1, so this term here. Let me pull out an R4, and I'm left with 1 plus R3 over R4. And so again, this is V2 minus R2 over R1, V1. And as you can see now, this R4s cancel out, and I'm left with R2 over R1. This is 1 plus R1 over R2, and this is 1 plus R3 over R4 times V2 minus R2 over R1 times V1. Again, this solution, right, is the same as this solution we had above here. And that's one way of getting your V out, okay? But let me do it in case 2, which I actually tend to like case 2 a little bit better. It's a bit easier. So let me move it to the left so we can kind of see the VA. So we said that we need to equate these two. So then VA, which is R2 plus R2 V1 plus R1 VO over R2 plus R1 is equals to VB here, which is R4 V2 over R3 plus R4. I'm going to solve this in one step, but I'll walk through it. So I'm going to leave VO on the left-hand side, and I'm going to say VO is equals to, I'm going to leave this whole term, so R4 over R3 plus R4. I'm going to multiply by this term times R2 plus R1. and then I'm going to divide by R1 to cancel that one out. So then this is V2, and then I'm going to subtract R2 V1 over R4. Okay, so again, as you can see, just in one step, we get our V out, and again, that's the same as here. And if you have any questions about this, again, please leave a comment in the description below, and I'll be sure to get back to you. So let's go ahead and solve this problem based on this equation. But again, these two are the same, and you can do both, and you should get the same answer. Let me list our values first. So we said that R1 is equals to R3, which was equals to 2K. And R4, or let me do R3 first. R3 is, R2 is 30K, and R4 is 20K. So let's go ahead and plug that in. So we get V out is equals to, and we also said V2 is equals to 2, and V1 is equals to 1. So V out here is equals to 20 times 30 plus 2 divided by 2 plus 20 times 2, and V2 is just 2 minus 30 over 2 times 1. Okay, you do this, you're going to obtain 14.54 times 2 minus 15 times 1, which is 14.09 volts. So this is your answer for V out. Again, if you plugged it into here, you should get the same answer. If you don't, please let me know in the comment section below, and I'll be sure to get back to you. If you like the video, please like the video, share the video, and subscribe to my YouTube channel. Thank you.